Today I would like to give you guys a brand new presentation. It's been a very long time since I have made a video, and during my isolation, I've been having a job actually, which is kind of crazy, but I seem to have some time off from my job now. So I will be able to give you guys this presentation / behind the scenes of what I'm currently up to. And for that, I want to talk about this very special thing that's been rather close to me recently, as well as making this my priority, which is all about data classes, but also about metaclasses themselves, and also how they work, and understanding why they should be implemented more at a low level. So with that, let's go to this next slide that I've just clicked on. But before I talk about that, for those who are not familiar with what a metaclass is, they are used as boilerplate objects. They are used as objects to create objects. You can think of it as being a base plate to put something onto. You could picture this as having a 6x6 Lego plate and putting some Legos and other things onto it. That's basically what a class does. That's what it is, where you're building off of it. Now, understand that as of currently, it is pretty difficult to implement this at compile time. And I'm going to explain why I have wanted to pursue this now, and what has been my inspiration behind doing so. So, what has inspired me to chase after doing Python metaclasses in low-level languages? So, originally, I thought SQL model, which I actually used to use, I found it to be sluggish and rather slow. And I didn't necessarily enjoy that, relationships and other things would not get compiled with JSON when I would go to convert it, stream it from a server, etc. With the lack of certain features in SQL Alchemy, with that SQL Alchemy being used in SQL model, it became very clear to me that with the current pull requests that were trying to be attempted, that there was no way that any of this was going to go through in any short amount of time. So it became my idea that instead of trying to fix SQL model, why don't I instead encourage friendly competition? And this is where I began exploring ways of making a faster version of SQL model. Maybe not with the libraries it currently uses, but with comparable performance, if not faster performance. So, one of the things that SQL model runs off of is pydantic. And pydantic is good. Don't get me wrong. I don't want to piss off any pydantic devs in any way, shape, or form. Just know that. But some say it was created using Cython, but after doing my research, I found that this is just not the case. Maybe there's an archive of it where Cython is implemented, but I have not found anything about that, and I just think that this whole thing was a flat-out lie. But anyways, I'm going to talk more about pursuing faster performance and about why performing metaclasses at compile time or in low-level languages is a good idea. So if we wish to make SQL model better, how should we approach changing it? Or start encouraging that friendly competition I've been teasing about? Currently, I am working on several different approaches in case one were to fail. And I call this technique brute forcing, where I'm trying out multiple things until one of them works. And there have been several attempts by me to actually, make something faster and better. Which the first one I did was trying to merge Msgspec with SQL Alchemy. For those that don't know what Msgspec is, and I forgot to make a slide for it, but Msgspec is written in C. It's written for C Python, and it's very good with creating data classes. And it does it in such a way as to where the metaclasses instructions are known at compile time, which actually was what inspired me to do this whole presentation and slides and everything. But one of my ideas was that if the Msgspec SQL Alchemy couldn't work, and I couldn't find any research into helping me merge the two, the second thing I started looking at was low-level metaclasses. And I would name it heapstruct after the Python heap type object, which sadly that object doesn't have a whole lot of documentation for it. I think there should be documentation for it, even though the C Python devs don't really consider it to be like public, if that makes any sense. Implementing metaclasses implementing metaclasses in Cython or Rust would actually be a lot more maintainable than just writing it in C, if I'm going to be completely honest. And I think Msgspec could be used as the current blueprint. As you can go to their repo and under underscore core.c, you'll actually find its implementation there. And it can be used in 3.9 or higher, which currently 3.9 is the oldest version that has not hit end of life yet. So the first option that I alluded to was combining Msgspec and SQL Alchemy to create my library called SQL Table, which you can actually go find on GitHub. But currently, there are some very nasty road barriers that are currently preventing me from creating a JSON decoder. I've created an encoder that works, but as soon as I go to try and let's just say we would want to web scrape an API, and then we would want to take those data and we want to copy it to a database. Well, then this becomes a problem because the Msgspec decoder misassumes SQL Alchemy's mapped type hint as a container rather than the type that's in it itself. And I've tried hacking the annotations, and it has resulted in member descriptors being stolen, and that is very, very terrible. The other problem is that I have not figured out a way to merge Msgspec's struct type with a declarative base, which is also part of my problem. But hopefully this video encourages the Msgspec maintainers to look into these ideas more. The second option is creating our own metaclass object in C, which I'm calling heapstruct. But currently, there's no reasonable way of implementing it without borrowing from other written sources, which I find to be pretty disappointing. Its predecessor, known as Quickle, for me, was easier to understand than Msgspec was, but it has less features overall implemented to it, which can be good and bad. Now, while we can do Python metaclasses in C, it comes at the cost of time consumption, as well as either like giving up too quickly, etc. I just don't feel like I would have the time and energy to pour in and try and actually like do all this, especially since you have to compile everything and then test it, which can be kind of difficult. Now, I could easily do this in PyBind, but the road curve of PyBind can actually be pretty tricky for some people. That isn't to say that it's bad, it's just hard to learn. This isn't to say that it can't be done in C++, even though C++ has never been to my go-to language for everything. Like, oh yeah, like C++ this, C++ that. My problem with C++ is mainly the same problem as C, which is time consumption. But maybe I will get around to it someday if the other ideas don't end up coming true. But I will share with you the final option. But I consider my previous option and this one to be the most favorable. The final outcome, which is why I actually made this video, was encouraging Cython or Rust to implement low-level metaclasses. You will find that I've already proposed to do metaclasses at the CDEF level in Cython, but it was currently turned down due to its difficulty of creating, as well as being possibly unsafe. But I see creating data class libraries using these features if they were implemented, and I could see me writing even my own ORM, or object relational mapping library, if I decide that SQL Alchemy just doesn't do a good enough job. Maintaining the library would be a lot more simplistic than using C, like I explained before. And we could even implement our own macros, like the macros that Msgspec uses. We could implement those just fine, like I'm fine with that, even. I have already proposed to Cython about all this, which they turned down. I think I explained that before. But finally, for Rust, I've taken interest in Rust. In fact, I know a little bit of Rust myself. I just haven't really put a whole lot of it onto my GitHub yet. Maybe I'll do that in the future, though. But the one thing I like about Rust developers is that they're pretty relentless. They're actually as relentless as I am. I mean, I wrote WinLoop, and I was pretty relentless at... I'm very relentless at making things that are Linux only compatible with Windows. In fact, very recently, I took Duplicate and I made it into a Windows program called WinCut. You can actually find it on my GitHub. I actually pinned it. But they told me that it was in the works, but it may only be able to be used in newer versions of Python, meaning that most versions that people are using, which are 3.9, 3.10, 3.11, would all be cut from the equation, which I think is pretty disappointing and rather grim, even though there's already a blueprint available, which you can find in Msgspec's core.c library, like I explained before. But finally, I want to wrap this presentation up, as my research has gone rather deep into this, which is why I finally decided that it was time to make a presentation about it. I hope you will appreciate the time and research that has gone into this. It's been hard for me to find and grab a bunch of different things off the internet, and it's been hard for me to wrap these concepts around my head even. And it's been rather interesting to try and get these features implemented, even though I know that the situation could be grim. But I think it could be theoretically done. I hope this video inspires SQL model developers, especially pydantic, into optimizing their current libraries. And finally, I hope that the Msgspec developers will look into making it possible to do object relational mapping in the future. Because why should I write a class twice? I just think that's annoying. Anyways, I hope you enjoyed this video. I haven't made a video in a very long time. I hope this was informative as well as exciting. I hope this inspires you to join the arms race in helping me to create meta classes like this. I hope this inspires you to create your own data classes in low-level languages like Rust or Cython. Anyways, that is it. I love you all very much, and I will see you all in the next video.